Okay, we're recording and we're getting level, so that's good. Alrighty, everybody. So we'll kick off then. Have a look at the second notebook. Data structures. Having a look at some elementary data structures. And if you remember, we've had a look at these before. Had a look at the list in Python. We've had a look at the tuple, the set, and the dictionary. So we're going to remind you of those things and cover all the basics, and then we'll kind of give you some challenging, well, moderately challenging exercises, a level up from what you may have seen before. So if you need to refresh your memories on this, that's fine. Just have a go at some of the elementary exercises, just the fundamental exercises like setting up these structures. Once you can do all of that, then there's a chance to have a go at these exercises. Okay, so let's go through the basics and remind you of those. So just on those points, let's contrast the difference between an indexed structure and a non-indexed, or in other words, referenced structure. Okay, so if you remember back to lists, and you may have seen this before with arrays, in other languages potentially. We will look at the NumPy array eventually in Python, which is a throwback to the traditional array. But right now, using a list, remember we can get to particular indices, particular positions of a list. Okay, so if we set a list up to have 5 elements, do you remember which number they start at? 0, correct. So they'll go to 0 to 4, size minus 1, good. Same with arrays, very good. Okay, so if it's 0, 1, 2, 3, 4, we can get to any one of those 5 values that we put in the list via the index position. Okay, that's good. So that's an index structure. It's been indexed. All the positions in that structure have been given a unique number, a unique position in that structure. Okay, so by contrast, something that isn't indexed, something that relies on references, memory references. So we saw a memory reference in the first session, didn't we, with objects. So you might have structures which are actually referenced together. So if you had a chain of items, values, or objects, you could have a memory address of the next one in the sequence. You can refer to it through the reference rather than by index. So you might have the first one in the list refer to the next one in the list, and then that one refers to the next one in the list, and that one to the next one in the list. We call that a linked list. The items are linked together, they're chained together. Okay, so you'll see that again in the next few sessions, the difference between how a linked list operates versus how an array operates. Okay, and the Python list that we have is a kind of a hybrid between the two. So we'll see it's got index positions, and it also makes use of pointers, references to objects, as opposed to just stored in a contiguously allocated set of memory, which we would see in a traditional array. Okay. Another example of a non-index structure would be a stream of data. So think of when you type stuff in on the keyboard. That would be a stream. That would be input from the keyboard, just continuously flowing data. It's not been indexed yet. It is just coming in as a flow of data. So that's read in one go. Just start from the top and get to the end. Okay, there's no you can't get to a middle word by an index. You can't go to position 75 because it's not there. Okay, it's just a flow of data that's read in. Same files. So if you're reading in from a file, that's a stream of data as well. It's just read until you get to the end of the file, the end of the data. Okay, so that's basically the opposite of an indexed structure. We can get to particular parts of it. And by the way, if you ever wonder about RAM, you've all got RAM on your machines, your various devices. That is indexed. That's why it's so fast. Okay, that's why it's so fast, because you can get to anywhere in the RAM because it's all indexed. You just point it to a particular place and it goes straight there. You don't have to start from the very top and kind of work your way through sequentially to get to that item. Okay. That's the trade-off there between those two things. All right, so we're going to see more of this. This is a good theme for us to be aware of at high level. Okay, and as we mentioned in the previous session, this is going to affect the performance of our data structures. So if it were an index structure, like an array, we can get access to things in constant time. That's very good. It's going to be the same accessing element 5, same time as what it would take to access element 100, element 1,000, element 1,000,000, 2,000,000, whatever it is, because it's all constant, it's all indexed. We can go to any position there, okay? But of course it has trade-offs, because if it's a fixed size structure, A, we can't go over that fixed size structure, and B, if we want to move things around in that fixed structure, then we have to kind of have some shifting of values, okay? Unlike a linked list, where we can just put things in the middle of the list. Once we navigate to that position, sequentially, we can just move the pointers in a reference structure, okay? So there's lots of advantages, disadvantages with those two types of structures, and indeed, we're going to start classifying them. I mentioned constant time already. Linear time would be also good to be aware of, O of n, because that would be sequential. So you start at the very first element and you just navigate through one after another, go to the next element, go to the next element, go to the next element, until you get to the end of the list or end of the file. Okay, so time taken to get through the structure will be dependent on how big the structure is, the value of n. So if you've got 5 items, it's, O of n, n is 5. You've got 50, it'll take you, 50 times the amount of time, so it's all proportional to the size of the structure. Okay, so let's just remind you about an array. Okay, so you might have done this outside of Python if you've used C or Java, C++ before. If you haven't, let me just tell you the basics. So we mentioned about the list earlier. Those share the name in terms of elements or defined positions within the list. Same in an array, we call them elements in an array. If we're in a language which is statically bound, like C, C++, Java, we would have to say up front what the size of the array is. It's a little bit different with a list. Python list, we don't have to specify the size. Indeed, it's flexible. We can add things on if we need to. We can append to the end of the list. We can put things in the middle of the list. It's quite easy to add and remove things in a Python list, but in a fixed-sized array, we'd have to specify up front. We'd have to say how much memory we need to allocate for the size of data structure. So if we're dealing with something like 5 32-bit integers, that's going to be 5 times the size of 32 bits. What's that going to be? 4 bytes? 32 divided by 8, 4, yeah, so 4 bytes. 5 times 4, 20. We need 20 bytes to be able to store 5 32-bit integers. So up front, I need to tell the RAM, allocate me 20 bytes because I'm going to put 5 integers there, okay? That's where it's all contiguously allocated, basically mean next to each other. So we have 5 sequential elements next to each other, means we can just iterate through them very fast because they're all in the same space. But with a Python list, they may not necessarily be in the same memory block. They might be in different memory blocks. Okay, it probably won't be too far from each other, but it's not quite as easy as just incrementing the pointers as it is in traditional arrays, because it's a different structure. As we saw before, they're objects. If we're storing numbers in them, they're objects of a class, okay? They're not primitive types, they're bigger because they've got more things attached to them, more references to all the functions we saw, all the different methods, okay? So it's not quite as easy as what I've just been saying. So we actually point to them rather than storing them in the contiguous block, and that might have ramifications for the performance. We will see that in a bit, but the main point here, with Python, as we saw, we can have mixed types. In other languages, you can't. Like I say, you'd specify the size of the array up front. You'd also specify the type of data. As we said, we need to make enough space for that type of data. So whether it's integers, whether that's characters, strings, whatever the data type is, the amount of memory has to match that. Okay, so different with Python lists. We can mix types. We just allocate that memory flexibly as and when we need it. Okay, so that's one advantage to that. Talk about strings. Okay, so in case you didn't know, I'm sure you do, that a string is treated as an array of characters. So here we go. There's our string. You told me it was a string earlier. Okay, so how many characters have we got here? 4. Yeah, exactly. So we could say that's position 0. position 1, position 2, position 3. Okay, so if I want to get to name position 3, what would I write? Or let's say, just to clarify, third character. If I want to get to, if I want to print out letter C, how could I get to letter C? What could I append to the end of name to get letter C? Oscar?
2.
Correct, yeah, position 2. Okay, so if I write here, name, subscript operator, that's the square brackets next to P on your keyboard. Position 2, as Oscar says, let's just run this, check we're okay. There we go, position 2. So within the square brackets, can write the index and get back a particular letter. Okay, so that's by index. It's an index structure, so I can go straight to the letter C via the index if I know it. If I don't know it, I've probably got to search for it. Where is it? Where is letter C? There are methods that help us do that. Okay, but the point I'm just about to make is that I can get to position or element 3, which is actually 4, the fourth character K, in the same amount of time as I can to get to position 2. Okay, so it's constant time, it's indexed, so it doesn't matter which element I go to, it's all going to take the same time because it's indexed. I can go straight there. Okay, so that's one advantage of it. All right. Just to show you, of course, we're talking about basics here, so you can loop through. If we had a for loop here, this is Python, so again, basics. So Python doesn't have the traditional C style for loop where you say for int I equals 0, I less than size, I++. We don't have that in Python, but we do have equivalent of a for each loop. So for something in something, for an alias in a structure, name, that's our string variable, our array. So for every x, for every character in name, print it out, okay? And I've got both a counter, I, which is my index, I for index, okay? And x for the character in name, okay? So there's I, 0, 1, 2, 3, and there is x, which is the character, N-I-C-K. All right, so that's just showing you how that works. Now, a slight technical point here is that I've used the plus sign here, concatenation from C, because you can get access to the C formatting, the format specifiers, rather than the Pythonic comma. So if these were all the same type, I could have used the Pythonic comma here. I've actually chosen to construct this with plus, so that's why I've got a temporary cast here. Have you guys done this? You might have done this a while back. So what I'm doing, well actually tell me, what am I doing here? I is, what type of data is I? Integer, yeah, correct. And I'm passing it to str as a function. So what's that doing? Typecasting.
Yeah, telling it to treat it as a string.
Treat it as a string, correct, both correct. Yeah, typecasting, treat it as a string. Yes, convert it to n so it can be concatenated with the rest of the strings. There are some strings, you see the speech marks, as we said earlier. So I'm just constructing a string, essentially. And I think the only reason why I do that, the alternative would be to write it with commas, as I just mentioned. So let me show you that down here. I think the only reason why I didn't is because of spacing. So if I replace the plus signs with commas, as is Pythonic, I think I'm just going to get more spaces. Yes. So if you compare the spaces to here, I mean, it's still readable. It's just a bit more spaced out. So the Pythonic comma adds a space. So potentially I could format that at the end. I could have an extra formatting thing there to say, you know, don't put spaces in. Yeah, just showing you the difference. And I think let's just test to see whether this means I can remove typecasting. Let's have a look at this. If I just remove those casts, let's have a look. Yeah, okay, so with the Pythonic comma, it can do that. It can adapt integer I to become a string. And of course, that's already a string anyway. But like I said, it's just formatting. So that's why I use the plus sign, ease of formatting, okay? But anyway, we get the point, All right, so let's keep moving. Okay, yeah, as mentioned there. All right, so you've seen dir before, whenever I did that for the types. We used it with floats, we used it with integer. Guess what? You can use it with string too. So again, let's have a look at what's in the string class. We've got some useful methods here. Remind me what these are. Double underscore, otherwise known as... Thank you, Malika. Dunder, yes, Dunder, here again. So you've been coding a lot of this, haven't you? This is what you've focused on in the previous session. Init, the initialization method. Okay, they're there as well. So you'll see a lot of these methods, these double underscore methods, built into pretty much every class. But these are the functions we're more interested in. If we have a look at them, we've got a lot here with a string class. We've got capitalize, count, ends with, find, that's going to be helpful. Index, is it one of these classifications? Is it a digit? Is it a decimal? Is it lowercase? Is it uppercase? Is it out? All these different classifications. Is it ASCII? We've got these useful checks that we can perform, Boolean functions. Is upper? We can join strings together, convert to lowercase, we can replace, we can find, split, strip. We've got lots of different things that we can do. Translate, uppercase. So there's loads of helpful functions, or methods I should say, technically, that come with the string class. So again, things for your toolkit. Get used to using these functions, these methods. Here we go, we're going to use one of them. So name.find, find, if I pass C to it, what's that going to return? 2 is referring to what? Here. Of name, remember it's NICK. C is at position, yes, if it's 0 index, yes. Third, if you count chronologically, yeah, position, it's in element 2. So it gives me the index, doesn't it? It finds me the index position of a character, of a string. You could pass a whole string in there if you want to, but here, just a single character. Okay, good. Yeah, so it's going to return that. So if I didn't know where it was, and I needed it for a certain algorithm, I could get it to find it for me. Where is it? Okay, you could construct this manually, of course, but we might as well make use of what's given to us and what's available as part of Python libraries. Okay. Oh, what's going on here? Find capital C, and the return of that is -1. What do you think's going on there? It's not there. So -1 is basically the negative case. It's saying it's not there. Now, I guess you say, well, why -1 or something else? Well, I suppose it couldn't be a positive integer because that would be confused with a actual character that's positive, right? I can't give like 1 or 2. 0 could even mean the first letter, couldn't it? The first character, so it can't be 0. So -1, I guess, is a good way of giving me an integer back, but something that's not going to get confused with a location in the array, just in case it's there. Okay, so -1. So basically you can have an if statement, can't you? If else. If it's positive, if it's above 0, here's the position. Else, if it's negative, error, not found, or something like that. Okay, so there we go. Positive, negative, very good. You can transform your all of your casing to lowercase. That's probably useful with validation. So if you're getting users to enter stuff from the keyboard, use a mixture of casing, uppercase, lowercase. You might want to halve the number of things you have to check by converting it either to lowercase or to uppercase. For the purposes of checking, I should add, maybe when you store it in your database or store it somewhere, you want to maintain the original casing. But notice that you can quite easily transform the data to perform checks. So here, convert to upper, here, and convert to lower. Okay, so there's just a handful of useful functions that are given to you as part of the string class. Okay, it's all stuff you saw before. You know what a string is. We're just pushing it a bit further to play around with some of those different methods. Okay. All right, and since we talked about lists, let's go on and have a look at them. All right, so as mentioned, we don't have to specify the size of our list up front. It's not a fixed array. It's not even a static array. It's not bound to a certain type. Okay. It does use the same subscript operator. It uses the square brackets as arrays in C, and you're going to see that with NumPy. Okay. It's also indexed. So as you saw, I can get to position 2, 3, whatever, via the subscript operator. Okay, so that's helpful. But they're stored very differently in Python. As I say, it's maintaining a pointer to objects. Remember we said all those types you saw in the first session, they're all classes. So all the values you store are objects of said classes. So they're not primitive types, they're objects. So we then point to where that object is located. So actually our list is maintaining a lot of pointers, a lot of references. And that is what enables these lists to be resizable, because we're not specifying memory up front, okay? We're just adding pointers to it. No worries. Okay, and we can also mix types, because again, we're just pointing to different types of data. They're not of a certain size, it's not of a certain allocation. Okay, so that's interesting. That tells us quite a bit. So here, notice we can mix types in our list. Here we're creating a list, L for list, square brackets, and notice we've got an integer, floating point, string, Boolean, all the types you want. You can even add your objects of your classes that you created, okay? And we can store them all in the same list. They're all pointers. They're all pointing to those objects wherever they are, okay? Maybe we could find out where they are if we printed them out, okay? Get the memory address of them. But maybe that's just simplifying. Let's have a list of digits, integers, okay? So you've seen this. We can get to the different positions. Remember, we can also count back. -1, that gives us the end of the list, all right? So that's a good Pythonic feature. If we didn't know exactly how many elements we had in our list, if we said -1, we'd just get the last one, whatever that is at the end of the list. So they're constant. We know 0 is going to be the first one on the list. We know -1 is going to be the last element of the list. Okay, so that's useful. That's good. That's helpful for us. Okay, so there we go. -1 for 6. Very good. -2, we start counting back. So 6, 5, 4, 3, etc. So again, useful just to jump right to the end. How much do you remember about slicing? List slicing. Returning a subset of a list. If you remember about this, let's just run it through. Okay, so 2, 4 gives us a subset of the list. Let's refresh our memory on the actual list. Let's pop it in there. List, there we go. 1, 2, 3, 4, 5, 6. Now, 2, where does that start? 0, 1, 2, 3. Okay. And then 4, 2, 3 is 4. And then, do we get 2, 3, 4? Do we get the 4th position in the output? We don't, do we? No, so it stops 1 before the upper bound. So remember, we start at the lower bound. 0, 1, 2 gives us 3. Okay, and then 2, 3 gives us 4. And then 4 doesn't give us 5 because we stopped 1 before it. Okay, you put that to the test as well. If I increase that, we'll get 5. So if we go to 5, which is 6 there, we'll get 3, 4, 5. So this is just the thing to remember. Start at the lower bound, but go up until 1 before the upper bound. Start at the lower bound, go 1 before the upper bound. All right, so it's exclusive. Inclusive of 2, exclusive of upper bound. All right, so again, useful ways you can return sublists of things. You might want to cut down data. You might get a whole array of different data being passed into as one variable. You might want to get subsets of it. So from cutting out the white spaces, maybe getting certain parts of it for formatting. So it's really helpful that you can do that quickly with lists. Okay. Yeah, of course, type applies here too, as mentioned. And guess what? We can check the directory as well. So hopefully you're getting the pattern. Dunder methods, there they are. It's probably got an init dunder method there. Yes, it does. There you go. So hopefully we're starting to see the theme. All right. And as mentioned, it's got some useful methods. So won't go exhaustively through them all, but just to let you know some of them. So append. Let me ask you, where would append add a new value? Would it go at the end of the list or at the start of the list? No, it's not actually related to stacks or queues. No. It's if you translate the concept, you might be able to argue it. But think about those prefixes, app and pre. Pre sounds as if it comes first, before, yeah, like a prefix. What was it? A prologue before a story. Prologue is like coming before, and an appendix of a report or as an essay comes at the end, doesn't it? So append, going to put at the end of the list, yeah? So if you append something, you put it at the very end, all right? So yeah, just remember the difference, those two. Append and prepend. Start of the list, append, end of the list. Okay, we've got count up the number of instances. Index, that gives us the index of a certain value. Insert, pop, that's stack terminology, by the way, pop and push. If you pop from the top of the stack, that gives you the top elements. We've also got remove, yeah, so remove stuff, reverse and sort. So again, useful methods, stuff to be aware of, that might save you time, okay? So we'll keep moving because of time. But yes, there we go, append, remember we had 1, 2, 3, 4, 5. There we go, 6, 1, 2, 3, 4, 5, 6. And then if we append 7, we add 7, there you go, and we can also remove it as well. There we go, so append to the end of the list. Good, so trust we're happy with that. Let's look at tuples. Okay, there's a second. Do you remember the difference between a tuple and a list? What's significant about the tuple? There's a clue in my bullet points. In contrast with a list, tuples are second bullet point, constant. Yeah? So once they're declared, can't reassign them. So in other languages, you might see const, C-O-N-S-T, const, but we don't have to use that keyword in Python. We can just simply declare a tuple with this pair of brackets. Okay, so remember, list has square brackets, tuples, curly brackets, parentheses. All right, so, and actually that's going to become very important because you might not, it depends on what you call your variables, but they may not have any keywords regarding list or tuple in them. So a way to tell them apart is by the brackets. You'll have to check the brackets for whether it's a tuple, whether it's a list. Okay, so here we go, there's the curly brackets. 1, 2, 3, 4, 5, 6. It's a tuple, it's not a list, okay? That means it's constant. We still index it, we can still get to certain index positions, that's not a problem. It's an index structure, as mentioned, constant time access. But here, have a look at this. If we try and assign a value, do you think that's going to run or not? Am I going to get told off? Could I do this? No, because it's constant. Can't do it, and we're going to get an error. Okay, so if we try and run it, we'll get an error. Tuple does not support item assignment. Okay, it only allows you to initialize it once. So when you're starting, you can assign them all in one go. So 1 through 6. Okay, but later, if we're trying to assign something to it, no, not going to allow you to do it. All right, so just be aware of that. So it's good for maintaining constant things that aren't going to change. So maybe for coordinates. Indeed, some of the exercises later, you might want to make use of tuples just to protect things. Good for pairs of things, again, not going to change. You think of like chess moves, they're always going to be constant, they're never going to change. Like the L formation of a knight is never going to change. So it's useful to protect those with tuples. Okay, and again, of course, it's got a directory. So hopefully you're getting the idea now. we've got access to methods, count and index, less perhaps than the list, because it's not as amenable as a list. We can get the count of items. So how many instances of something do we have? So it might be useful for tallies. You can actually count up things. And we can also get the index of a value. So how many ones are there? And actually, if we let's create T1, and let's give it a number of ones. Let me get this right. 1, 1, 1, 1, 1. Okay, and 2, 2, 2, and 3, 3, 3, 3, 3. Check we got that okay. And we can apply count. Give me how many ones there are. Yeah, it's counted up that there are 5 ones. So that might be useful for tallying. There's a mode question, by the way, getting you to find the most frequent value later on. So this might be helpful for you. We've got a preset function that can do that. Okay, in part of the tuple class. So let's check that. Yeah, 9 2s. That's helpful. And again, count the number of 3s. All right, so that's a useful function to know. And then, of course, index. So in the original tuple that I had declared above, 1 through 6, it gives me the position of 5, was it? I think I was looking for. I can print that out. Yeah, the value 5, by the way, not the position 5. Two different things. Let me just print T so you can see it again. There we go. 1, 2, so 0, 1, 2, 3, 4, 5. So give me position 5. Give me the position. Yeah, sorry. Give me the index of value 5. There we go. We're getting there. Value 5 is at position 4. Got it. 0, 1, 2, 3, 4. There we go. That's what I was trying to say. Okay. So give me the index of value 5. So value versus index. Just make sure you got them. All right. So there we go. There's our first section. There's compile starting a class. So just remember, tuples immutable, constant. You can't change them once they're declared. A list is mutable. A Python list is mutable. You can reassign as and when you want to. You can append. You can remove as and when you want to. It's not fixed. It's flexible. Okay, so just remember the differences between the pairs of brackets. All right, and they're both indexed, so you can both use the subscript operator to get to them. Okay, sets. So guess what? We've got a third type of bracket now. You've seen the square brackets. Square brackets refer to what data structure? Hello to be, yeah, it's all right. The square brackets we would refer to as a list, thank you. Yeah, and tuples have what? Apparently is very good. So we've got a third one now, which is the curly code braces. Like a coding block in C or in CSS even uses these. JavaScript would use these too. Most languages apart from Python would use these for a code block. We don't need to write them in Python, but Python's reserved them for sets and also for dictionaries, we're going to see in a moment. Okay, so sets, like mathematical sets, one of the unique features of that is we don't need to store duplicates. Okay, we can, well, it doesn't store duplicates. If we had duplicates, it just won't store them. So it's, we don't need to worry about that. It's only going to deal with the unique values, okay? And they are mutable, so we can change them, all right? So here we go, here's a set of numbers, all right? 1 through 6 again, okay? And we can add things to them. We've got add functions, we've got remove functions, so add 7, okay? So hopefully you're getting the gist. Similar types of things that we can do, the classic operations, okay? Let's just show you the duplicates. So, all right, so we've got 2 sets of 1 through 6 here. There's the first sets and the second set, but we only store the one copy of the first of these numbers. Okay, we don't store the duplicates, just one instance of them. So a good way to remove duplicates. If you've got a list that contains a load of duplicates, well, cast it to a set and get rid of all the duplicates. All right, so it's a good, efficient way to do that. As I'm going to demonstrate for you here. There we go. There's the list full of duplicates, copies of all these values. We're typecasting to a set, and we're removing them, all right? And we could easily cast it back to a list as well. So it's very flexible, very useful. There's the mathematical set theory. Okay, so if you've done maths before, you will know this. Remember the Venn diagrams? You've got 2 sets, 2 circles. If they overlap, you've got an intersection in the middle. Okay, so that would be A and B, I think. If you're writing a mathematical formula, I think it's that. And then you've got AUB, union, which is the OR, vertical line in Python. And difference, that's subtraction. So you could subtract one set from another set, okay, just to get the unique numbers of a certain set. All right, so very quickly, there we go, sets. This is intersect, so what's common between both of these? Well, we've got 1 through 6 here, and we've got 4 through 9. So 4, 5, 6, you can see, is shared by both sets. So if we do S1 and S2, there we go, we've got the intersect there. All right. Union, what's that going to give me? If I ask for the union, what values do I expect to see? Anyone? 1 through 9, yeah, all of them. Yeah, because it's both, isn't it? It's both the values of that set and the other set. If there's any overlaps, 4, 5, 6, we only need one copy of them. There they are. So you've got the unique features of S1 and the unique features of S2 alongside those two. Yeah, so it's a good way to get both, all the unique values of both sets. Finally, set difference. If I subtract S2 from S1, we get the unique features of S1, don't we? So 4, 5, 6 is in both S2 and S1, so take that away from it, and you get 1, 2, 3. All right, so then flip that round. S2 minus S1, we get the reverse. So we get the common features, we get the unique features of S2, okay, because we've subtracted 4, 5, 6 from S2. All right, making sense? Kind of happy? This is kind of elementary stuff, really. It's going to be about how we apply these and how we use the methods of these different structures to perform operations. Okay, find things, locate things, change things, get subsets of, modify in some way. Okay, so just running through the basics for you, just trying to explain best I can. All right, the final of the 4 dictionaries, and guess what? We're using the same pairs of brackets, the braces, but what's different about the dictionary? Let me ask you that question. What's unique about the dictionary? Does anyone want to give me what it is? What? Think of a normal dictionary, English dictionary, Oxford dictionary. How's it formatted?
Contains specific information.
Yeah. And how do you locate specific information? What do you look up? Yeah, letter, word. Yeah, so you look up a word, don't you? What's the definition of this word? All right, if I'm interested in, what's the definition of programming or something, I look up keyword programming and see what it says as a definition. So, for term, think key. That key gives us access to the definition, dictionary. Here it gives us access to a value, V. K for key, V for value. So it's K colon V, all right? Comma, K colon V, comma, K colon V, comma. All right, so we have pairs of keys and values. All right, so this is what differentiates it from the set, because there's no keys, there's just values. All right, so it's just value, comma, value, comma, value, comma, value, comma. All right, so that's how you can tell the two apart. Same brackets, but different information in them. So look for the colon. All right, so we're operating on that principle. A key is our term that gives us the definition, gives us the value of it. All right, similar to an associative array, or we might have used a map in some languages, Java, same sort of principle. It's pairs of values. Okay, so the advantage of that, it allows us to have non-integer keys, because before we've looked things up via the index, which has always been a integer, zero index, okay, but here we can have non-numerical keys, we can have meanings, we can have words, okay, in this particular example, countries, okay, with a defined value. So there's our key, and there's our value after the colon, okay, K colon V, K colon V, K colon V. All right, so print that out as D, we would get thus. And, let me ask you, what's going on here? Square brackets. So is this the key or the value? The key. Thank you, it's the key. And what do we get as a return? Value, very good. Yeah, so we can look up by the key, it will check to see what matches. That's the value, return that. Just like I say, look up, where's Python in my dictionary? Let's have a look. There it is. Python, what does that mean? Here's the definition of programming or Python, or whatever the word I'm looking up. Okay, so that's what the word's going to do. It's going to look up to find a matching key and then give you the value. All right, so there we go. That was nice and simple. What's going on here? We get an error when we type in lowercase uk. The problem is, what's the problem? UK's there, right? Isn't it? There's UK. What's the one I got there? Lowercase, yeah, you got it. It has to match exactly, okay? Especially with strings. Remember what I said earlier, upper, lower. Just be aware of that. You might want to cast to one or another. So maybe when you check your keys, just check if it's all lower or all upper, all right? Just to remove this type of problem, all right? Because it's easily done. You've got a very specific casing, so you can remove that by using upper or lower. Okay. Append. So before we've used the append function of lists, okay, but what's going on here? We established this was the key, all right, and we established this was the value. So at this key, if it doesn't exist, and it doesn't, there's no Asia in this list, so therefore create a key and add the value. Hence we will see that here. Okay, so we have to provide both details. We can't provide a key without a value. Likewise, we can't provide a value without a key. So we have to provide both of those two things. Now I've got pairs of data. There we go, key and value. Give us that. All right. And let's just check remove. Ooh, del. What do you think del refers to? Delete. Yes, correct. Delete. Yeah, that's actually C. Del for delete. It might be delete in C++, I think. And why would we use this? What's the reasoning here for having a special keyword? Because before, if this is the first time we've seen it, it's there for a reason. And think about how many types of data we're dealing with here. We've got pairs of values, and we've got pairs of keys and values, haven't we? So when we delete something, do we want to delete one or both of those things? Yes, exactly. So that's the thing here, isn't it? If we delete just the value, we're left with a key. And likewise, if we delete the key, we've got no way of getting to the value. So we have to delete both, really, don't we? And like I said, we don't want to delete the key first, because then we can't get to the value. So we have to first get to the memory address of the key, go to here, delete that, working backwards, and then delete that. So where were we? Asia, okay. So we do it here. So go to the value, delete that, and then delete the key, because they're both data, so they both have a memory storage location. We have to make sure we clear up both of them, okay? Because if we leave the values, that's what's called memory leaks, where data just hangs out there, but there's no way to get to it because we lost the reference, we lost the pointer, all right? So that's why this delete keyword comes into play. We don't need to do it for both key and value, we just write the key, okay? And thankfully it manages it for us. It will go and delete the key, delete the value, and then the key. All right, so that's a good thing to know for dictionaries if you need to delete things, all right? Seen the type, and of course it has a directory. Okay, so again, useful to know some of the methods that come with it. It might be useful for you. Updates, pop, stack language. Okay, so useful to know all this stuff. And finally, we're coming into land. Here we go, keys and values. That's one of the useful functions that comes with this method, that comes with this class. What do they return? You've got square brackets here. What do square brackets mean? What do they refer to? Thank you, lists. So it returns a list of your keys and a list of your values. So that's useful if you want to separate them, okay? So good to know, all right? So you can print a list of the keys and a list of the values, all right? It might be useful for some of your exercises if you want to have a go at those. All right, so let's wrap up and then take a break. All right, so just in summary, here we go. Lists, square brackets, as you told me, very good. They're mutable, you can change them, all right? You can add to them, they're flexible. You can store any type there in Python, okay? Because it's not technically an array. It looks like an array, it feels like an array, it's a list, all right? It's a slightly different behavior to a NumPy array. We're going to see that in the next session, all right? But it is a list that uses square brackets, so it's indexed, okay? We can get to positions in constant time, useful. Tuples, we established they use the parentheses, curly parentheses, curly brackets, okay? Separated by comma, immutable, can't change them, okay? Think immutable, mutate, it changes. I always think of COVID mutations, okay? So it mutates, the virus mutates. Immutable doesn't mutate, doesn't change, all right? Just technical words for that, okay? And We've also then got sets and dictionaries. They both share the braces, but how do we tell them apart? Well, remember we said it's key and value, isn't it? Colon. So if you see a colon in between the co-braces, you could assume it's a dictionary. If you don't see a colon, you see a load of commas, you could assume it's a set. All right. And I forgot to mention, by the way, sorry, that dictionary is very close to JavaScript. JavaScript object notation, JSON. So when you get to work with web, if you go on to look at Flask, and you get data back from APIs as JSON, that's usually in this format, key and value. You've got the attribute and its values. So it maps very nicely to a Python dictionary. So we'll probably have a look at that actually in some of our exercises. Mapping JSON objects to Python dictionaries, very useful for getting data from the real world. APIs, you should all be getting to use them, they're useful. Okay, so that's another good thing about a Python dictionary. Okay, and of course we said with sets, no duplicates. Indeed, if we convert a list with duplicates, it's going to remove all of them. That's fantastic. Good for getting rid of duplicates and giving us the unique values. Good for data cleaning. Again, the machine learning guys will probably do a lot of that, cleaning out duplicate rows and missing rows and things like that, missing values. So good for doing a bit of that. And dictionaries, yeah, very fast lookup as long as you get the match. As long as you know what your key is, but just be aware of memory overhead and memory leaks. So don't delete the values. Don't delete the keys without deleting the values, okay? Because otherwise you'll run into problems. All right, so there we go. Okay, so any questions, guys, on that? I've given you a lot of stuff. Just wondered if there was anything that came out of that. Any questions you want to raise on it? Are we all broadly happy? Followed that? Good. Okay, well, I hope that was a useful recap for you, because these are going to be our sort of basic Python types that we're going to build on throughout the module. Okay, so good to know the basics, good to know where we can integrate them into all the other stuff that we're going to look at. All right, so I'll finish up the exercise, I'll finish up the lecture here. You may want to, if you spent a bit of time doing the OOP in the first session, you may want to start having data structures of those objects, because if you created a student object, why not have a list of student objects? Okay, and this is where you get to integrate your student.py or your student class, all your student objects, put them into a list, put them into a dictionary, put them into these structures. That would be a nice way to bring those two things together that we just talked about. All right, so I will pause here and